In this video, we're going to talk about radicals, adding and subtracting. So here's your steps. I went ahead and put them in here for you. So simplify your radicals first. That gets it down to the most basic form so that you can see which ones have the same radicand. Identify your like terms. Has to be the same index, so square root, third root, cubed root, or fourth root, and the same radicand. And then you can just combine your like terms by adding and subtracting the coefficients. And then your radical will stay exactly as it is, just like a label. So you're just going to carry that along as you do your math. So we'll look at a few examples and then I'll give you guys a chance to do your own practice. So we know that 27 is going to break down into 9 times 3. 3 is going to break down into 3 times 3. Now we know that this is an index of 2. So we're looking for pairs. So I have a pair of 3's here, which leaves this guy out by itself. So this radical by itself simplifies. We have a 3 on the outside. We have to multiply it by the other 3. That comes from the square root of 9. So 3 times 3 is 9. And then we have this 3 that is left inside the square root. Okay, we're going to do the same thing over here with 2 times the square root of 12. So we know that 12 is going to break down into 3 times 4. And we know that 4 is 2 squared, or 2 times 2. So there's our pair. So we'll pull the 2 out and multiply it by this negative 2, which will give us negative 4. And we have the 3 left inside, so that becomes our radicand. Notice both of these have the square root of 3 on them, so they are like terms. So we can say 9 minus 4 is 5, and then keep the square root of 3. So when we read this, it says 9 square root of 3 minus 4 square root of 3. So I kind of read that like if I had 9 square roots of 3 or roots 3, and I took 4 away from them, 4 roots 3 went away, I would have 5 left. Okay. Okay, so let's look at another one. The 7 cubed root of 3 is already simplified, so we don't have to do anything with that. Now, if I have root 3 in this problem, or the cubed root of 3, I know that I'm going to want the cubed root of 3 over here. So I'm just going to start by dividing by 3. So 3 times 6 is 18, carry 1, and that gives me a 4. And I know my cubed root, so I know that 4 times 4 is 16, times 4 is 64. So this would be 4 to the third. So this is actually my cubed root, so I'm going to pull a 4 out. So here I would have 7 times the cubed root of 3 plus, I pulled the 4 out, multiply it by 2, that's 8. And notice I still have my cubed root of 3 here. Now that I have cubed root of 3 on both of them, kind of hanging on like a tag, I can do 7 plus 8 is 15, and then keep my radical of cubed root of 3. Final answer. Okay. Number 3, we have the cubed root of 54. I know that I'm going to need the cubed root of 2 in order to combine these. So I can see 54 is even, so I can divide by 2. This is going to be 27. And I know that 27 is 3 times 3 times 3, or 3 to the third power. So I can pull that cubed root out. 3 times 4 is 12. And I still have the cubed root of 2 left here. Minus, and then we'll just carry down that cubed root of 2. Since we have cubed root of 2 on both, we can do 12 minus. Now remember that even though it's not written, if we say minus a cubed root of 2, we're talking about 1. And so 12 minus 1 is 11. So we have 11 cubed root 2 left over. Okay. Square root of 64, hopefully you recognize that to be 8. Okay, and so we would say negative 3 times 8 is going to be a negative 24, and then just carry down minus the square root of 8. And now we can simplify this. This is going to be 2 times 4, which we know is 2 times 2, so we can pull the square root of 4 out of there. You may have done that all in one step directly, and that's okay. That's pretty basic. So minus 24 minus 2 times the square root of 2 would be your final answer on that one.